Okay, here's my video for slide number 3 in lesson 511. And so in this beginning part of chapter 5, we don't know sine, cosine, and tangent yet. And we're in the process of developing that idea, that concept. And so they're doing this by first kind of refreshing what we do know and how we can find these missing sides of these right triangles here. And in this case, they want us to find two different strategies to finding the change in y, which is right here. The change in y is the change in the height of both triangles. We want to do two different methods for both. So the first method, because we have a leg of the right triangle and the hypotenuse of a right triangle, and we're just missing one side, and that's for both of them, we are allowed to use the Pythagorean theorem. And so we can use a squared plus b squared, my leg squared, added together equals my hypotenuse squared. And we can do that for both. So the first one, 3 could be my a, so I have 3 squared, because it's one of my legs, plus y squared, because that's one of my other legs, equals my hypotenuse squared, which is 6 squared. And keep going from there. I have then 3 squared is 9, because 3 times 3 is 9, plus y squared, because y squared is still y squared, nothing we can do with it, equals 6 squared, which is 36. Subtracting over the 9 so that we get y squared by itself, I am left with y squared equals 36 minus 9, which is 27, so equals 27. I can then square root both sides, and I'm left with y equals the square root of 27, which if I use my calculator, that gives me, oops, I want to get out of the square root. Let me grab my calculator. That would give me the square root of 27 is 5.196, and so I can round that to 5.2. Okay. We could do the same Pythagorean theorem for part 2 triangle. Just 1 would be our A, y would still be our B, and 2 would be our C. So you can check that one as well. But for time reasons, I'm not going to do that one. Okay. Here, we also want to find the second method to solve for y. And what we could do is actually use our tangent, because we have an angle here. We have our missing side y, and we have the run, which is 3. And so if we have rise, run, and an angle, or the way I say it when we use tangent now is opposite adjacent angle, I can use tangent. And how to set that up would be the tangent of my angle, which is 60. I put that over 1, because eventually I'm going to cross multiply here, and I can put anything over 1. And I set that equal to the rise over the run, or the way I say it now in our lessons, opposite over adjacent. And so that would be y is my opposite, 3 is my adjacent, and I can cross multiply and solve here. 1 times y gives me y, and the tangent of 60 times 3 I could write out like this before I plug it into my calculator. Now I'm going to plug this into my calculator, equals the tangent of 60 times 3, and that should give me 5.196, or if I round it again, 5.2. So I'm getting the same thing, both methods. And this is just kind of an introduction and review of how we can solve for these missing sides of a right triangle. But we also learn later in this lesson a new method that we could use with sine and cosine to solve for that as well. Now, to continue this and to finish the part B, we want to do the change in x of both triangles divided by the hypotenuse. So the change of x of this triangle divided by the hypotenuse, the change of x of this triangle divided by the hypotenuse, and the change of x is the same thing as the run of the triangle. It's that distance moved horizontally. And so in the smaller triangle, the change of x is 1, and the hypotenuse is 2. So that would be the ratio, 1 over 2. For the bigger triangle, the change in x is 3, the hypotenuse is 6, so I can write that out as 3 divided by 6, which reduces down to 1 over 2, dividing top and bottom both by 3. So we can see that they actually have the same ratio between their change in x and their hypotenuse. And this similar ratio not only tells me that these triangles are similar, because they actually have then side, angle, side, but it also tells me that there is going to be some relationship between these ratios. And we can use that ratio to start developing what we would actually look at as cosine, because cosine is the ratio of the change in x over the hypotenuse. Okay, But this is the two answers for A and B. If you struggle later in the lesson, let me know because that is an important development of our sine, cosine, and tangent.